Okay, Assalamualaikum warahmatullahi wabarakatuh. So let's proceed with the 2.2, which is properties of a function. So in this subtopic, we are going to determine whether the function is an even or odd function by using two methods, which is algebraical method or by using graphical method. So by using the first method, which is algebraical method, we have to substitute every x with the negative x in the function. So when you substitute x with the negative x, it is equivalent to the fx, meaning that the function is an even function. When you substitute x with the negative x, it is equivalent to the negative of fx, meaning that the function is an odd function. But if it is not equivalent to fx or not equivalent to the negative of fx, meaning that it is neither even or odd function. And then by using the second method, graphical method, if the graph is symmetric with respect to the y-axis, meaning that the function is an even function. But if it is symmetric with respect to origin, the graph is referred to the odd function. And if it is not both, meaning that it is neither even or odd function. So let's look at to the example of the second method by using graphical method. So if you look at to this graph, so it is symmetric with respect to y-axis. Why? Because when you put the mirror on the y-axis, so it is reflected to each other and it shows that the distance between left and right are equal. So meaning that this graph is symmetric with respect to the y-axis. So as a conclusion, this graph is referred to an even function. And then for the second graph, it is symmetric with respect to origin. So when you put mirror on this on the origin, so the graph are reflected to each other. Therefore, this graph is referred to an odd function. Now let's look at to the second method by using algebraical method. What we have to do here is for you to determine whether the function is even or odd or neither even or odd, we have to substitute x with the negative x. So let's look at to the first function here. When you have fx is equivalent to modulus of x minus 5 plus with the modulus of x plus 5. So what we have to do here, substitute x with the negative x. So you will get negative x minus 5 plus negative x plus 5. So substitute every x with the negative x. So what we have to do next here is we have to factor out the negative inside the modulus sign. So you will get here modulus of negative x and then plus 5 and then plus with the negative of x minus 5. And then what we can do here, we can apply the properties of modulus of A times B. We can split into modulus of A times with the modulus of B. So between negative 1 and the x plus 5, so we can split into modulus of negative 1 times with the modulus of x plus 5. Same goes to the other side, negative modulus of negative 1 times with the modulus of x minus 5. And then modulus of negative number is equivalent to the positive number. So you will get here positive. For the modulus of negative 1, you will get positive 1. And then next, what left is just modulus of x plus 5 plus with the same goes to this one. Modulus of negative 1 is equivalent to positive 1. So what left is only modulus of x minus 5. So if you try to rearrange this one, so you will get here modulus of x minus 5 plus with the modulus of x plus 5. So what you can conclude here, this function is equivalent to the original function. So this one, it is compulsory for you to write down. When you substitute x with the negative x, you get this one is equivalent to fx. So you get equivalent to the fx, therefore the function is an even function. So this is your conclusion. So please take note that it is compulsory for you to write down this statement and also what is your conclusion. You cannot simply up to this step, you know that it is equivalent to fx, but you didn't put this statement, you just jump to the conclusion it is an even function, so marks will be deducted, or you will just get mark for you to substitute x with the negative x, but you didn't get full mark for that. So it is compulsory for you to conclude f negative x is equivalent to fx, and then your conclusion it is an even function. Okay, so let's look at to the second function, 2x power of 5 plus x. So for you to determine whether this function is an even or odd, or neither even or odd, substitute x with the negative x. So you will get here 2 of the negative x power of 5 plus with the negative x. So this one you will get negative 2 x power of 5 and then minus x. So up to this step, you can see that it is not equivalent to the fx. So this one is not compulsory for you to write down. I just want to show that the function up to this step, it is clearly not equivalent to the function f. But if you try to factor out the negative sign, what happens? So you will get 2x power of 5, and then in the middle here will become plus x. So as you can see, when you try to factor out the negative sign, it is equivalent to the negative of function f. So it is not necessary every time when you try to factor out negative, you will get negative of the fx. So it is, if you didn't get equivalent to negative of fx, meaning that the function is not even or odd function. But in this case, when you try to factor out negative, you can see that it is equivalent to negative of the fx. So as I mentioned just now, so you have to write down this statement, f of the negative x, it is equivalent to the negative fx, therefore the function it is an odd function. So it is compulsory for you to write down this statement. So there are three possibilities when you substitute x with the negative x. So whether you get equivalent to fx, or whether you get equivalent to negative fx when you try to factor out the negative, or f negative x is not equivalent to f, or it is not equivalent to negative fx. So for the first situation, we can say that the function is an even function. For the second situation, it is an odd function. For the third situation, it is neither even or odd function. Okay, so I want you to try out the next question, part C, D and E. So we'll discuss during class. Thank you.